Last class, we started talking about similar polygons and the different ways that we can prove that triangles are similar to each other. And today we're going to be looking at the different parts of triangles and how they can create proportionality within the side lengths. So we're going to start with our triangle proportionality theorem. And what that says is if a line is parallel to one side of a triangle, so if a line inside is parallel to a side of the triangle, okay, and it divides and it intersects the other two sides, it divides the sides into segments of proportional lengths. So we're going to go ahead and write this out as a conditional statement. Okay, so if line DE is parallel to a side of the triangle, which we're going to highlight the side that it is parallel to, AC, then we know that it's going to split up the other two sides of our triangle into proportional lengths. So I'm going to highlight each length as we go. So the length of BD to DA, so the length of BD to the length of DA will be proportional to the length of BE to EC. So if a line on the inside of the triangle is parallel to the other side of the triangle and it intersects the other two sides, then it creates proportional lengths. Okay, so the converse of that is if we can show that the lengths are split into proportional segments, then we can say that the lines are parallel to each other. So the opposite of that. So if the length of BD to DA is proportional to the length of BE to EC, then we can state that that interior segment, DE, would have to be parallel to the other side of the triangle, which is AC. Okay, so lots of different parts. So basically all it is saying is part over part will be proportional to part over part, and that's what we're going to do some examples on. Okay, so I'm going to start with one side of our triangle here in example 1. You'll notice in example 1 through 6 all of our lines are parallel, so we get to use this proportionality theorem. Okay, so I'm going to start with part, which is 12, over the other part of the segment, which is 14, will be proportional to part of my other side, which is 15, over the second part of my side, which is X. So we're going to be setting proportions up for all of these today. Okay, so just like we were doing last class, we would cross multiply in order to solve this proportion. So 12 times X is 12X. 14 times 15 is 210. So my X value would be 17.5. Okay, part over part equals part over part. And we're going to do that another time here. It does not matter which side of the triangle you pick. We are just setting up ratios here. So I'll start with X on this one. So part of my side to the additional part of that side will be equal to the other part, which is 56 over 21. Okay, we would cross multiply to solve this proportion. X times 21 would be 21X. 18 times 56 is 1008. So our x value would end up being 48. Okay. Take it up a notch. If we look at number 3 and number 4, we have a little bit different. So we have an entire piece, an entire length here. So we would need to find that missing piece so that we could set up our proportion as we want to. So if we look here, if this entire side is 55 and this segment here is 45, I know this missing piece would have to be 10. And now this matches all of our other problems that we've done so far. So I'm going to start with part of my side, which is 10, part to part, so 10 to 45 will be proportional to part to part. We have a proportion with one missing variable. So we would cross multiply here in order to solve for x. 45 times x is 45x. 10 times 36 is 360. So my x value here would be 8. You would do the same process for number 4. You would have to find your missing part. You have your part and your part of one side. You have your part and you're missing this part, so you would subtract 6 from 27 and get your missing piece of 21 units, and then you could set up your proportion accordingly. I don't think we need to do number 4. Okay. Number 5 looks a little different. We have a binomial thrown in as a length, but we're going to use this proportionality theorem to set this one up just like we've been doing. Okay, so I'm going to start with this left side of my triangle. Part, which is 30, over the second part of that side, which is represented by x plus 7, will be equal to the top part over the bottom part. Okay, so we have a proportion. But now we have to be careful because we have 2 terms times 1 term, so we have to make sure that we multiply this correctly. Okay, so I have 25 times x plus 7. I'm going to write it out like you see it, just for this first one to make sure we don't make any mistakes. So we have to apply that 25 to both the x and the 7. 30 times 15 is 450. So if we distribute here, we would get 25x plus 175, and then we have a basic one-step equation that we can solve. So we would end up getting 11 for our value of x on this problem. Okay. Number 6, we would do the exact same process. Part over part. So part of a side to the other part of that side will be proportional to the top part over the bottom part every single time. Okay? We have binomials in the numerator and the denominator this time, so we have to be careful. So I'm going to start with this. I have 21 times x minus 1 will be equal to 6 times 3x plus 1. So you have to make sure that you are multiplying the 3x and the 1 by that 6. Go ahead and solve this equation. Make sure you solve it correctly and not incorrectly like I just did, because 21 times negative 1 is not 22, so negative 21. So we'll end up getting, let's see what we end up getting. X is going to be equal to 9. Okay, so part over part is equal to part over part. So now we're going to work backwards, where if we look at these pictures on 7, 8, and 9, it does not have any parallel marks on there. So if you look at the directions, it asks us to determine if MN is parallel to JL. So the only way that we can prove if those two lines are parallel to each other is if their sides create proportionality. So we're just going to work backwards this time. So I'm going to take part of a side over the second part, just like we've been doing, and set it equal to part over part. Okay, and if these two ratios simplify to the same number, so for instance, if I took both of these, and I'll get my calculator so you guys can see what I'm doing here. So if I typed in 11 over 15.4, I get 0.714, or you could change it to a fraction if you wanted to. Okay, so 5/7, so this reduces to 5/7. And then if I take my second fraction, which is 10 over 14, that also simplifies to 5/7. So those are equal, they are equivalent, they are proportional. So since they are, we can say, yes, absolutely, we know MN will have to be parallel to JL because those segments are split into proportional parts. Okay? So we're going to try this again. We're going to break this up into part over part equals part over part. So I'm going to do part over part equals part over part. And we want to see if these ratios simplify to the same number. Obviously, they will probably not. So let's take a look. So 4 over 15, that simplifies to 4 over 15. Cannot be simplified. If we take 5 over 18, that simplifies to 5 over 18. They are not the same. They are not equal. Okay? So if we do that, you will show that those side links do not create proportionality. So we would say no. MN is not parallel to JL. Or you could just write no. You didn't have to write that they're not parallel. And you would do the exact same thing for number 9. You would find out if you wanted to try this one on your own. You should get a ratio that looks similar to the following. And if you put both of those fractions in the calculator, so let's see, 24 over 30 simplifies to 4/5. And if I put 30 over 37.5, that gives me a decimal. I want to convert it to a fraction. And 0.8 is the exact same thing as 4/5. So those are proportional. So this would be a yes. Okay. Now, if we have 3 or more parallel lines that intersect 2 transversals, so you'll see our 3 parallel lines that intersect 2 transversals, then they cut off the transversals proportionality. Okay, so if we write an if-then statement here, so if line AB is parallel to line CD, which is also parallel to line EF, then it splits those transversals into proportional parts. So we are able to say that the length of AC over the length of CE will be proportional to the length from B to D over the length from D to F. So you'll notice it looks pretty much the same. Part over part should be equal to part over part. Works the exact same way. So you'll notice in 10, 11, 12, 13, 14, 15, we have 3 parallel lines in all of those examples. So we know we get to apply this theorem to it. So we're going to follow the same steps. I'm going to take the distance from my first 2 parallel lines, so 45, to the distance of the second and third parallel line, which is 18. And it should be proportional, not should, it will be, since we have parallel lines, to the distance from the first to second parallel line, which is 52, over our missing length, which is x. We have another really easy proportion here. So when we cross multiply, we'll get 45x equals 936. So we end up with an exact decimal of 20.8. Remember, if we get a repeating decimal, we want that answer to be as a fraction. Okay, I think that you guys will be good with number 11. You would still do part over part equals part over part. Okay, does not matter which part you start with as long as you're picking the corresponding sides to go with each other. All right, if we take a look at number 12, you'll notice that we have the distance from line 1 to line 2 being 27. And the second distance on that side is x. And I'm going to set it equal to the distance from line 1 to line 2, which is 18. And then we have to figure out what that missing little distance is. So if we figure out 32 minus 18, we should get 14 is our other part of our proportion. Okay, so sometimes you're going to have to do a little bit of subtraction. So when we cross multiply here, we're going to end up getting 18x equals 378. Solve for x, and you should get 21. Okay, you would do the exact same process on 13 as we did on 12. I think that we can probably skip to number, let's do 14. I'm sorry, let's do 15. All right, so we have our 3 parallel lines that are intersecting 2 transversals, and we have our distances that are cut into proportional parts. So I'm going to start with 2x plus 2 over the second part, which is 21. And I'm going to set that equal to the corresponding parts on the other side, which is x plus 3 over 12. Okay, we have binomials here, so when we cross multiply, we have to be careful. All right, so we're going to get 21 times x plus 3, so 21 times x plus 3. And then 12 times 2x plus 2. Wrote a little small here. There we go. All right, when we distribute, I bet you guys can do this without me. Go ahead and solve for your x. And you should end up getting x equals 13. Okay. So now we're going to look at how different parts of triangles create relationships. Okay, so we're going to look at altitudes, angle bisectors, and medians. And we're going to see what they can do when I have 2 similar triangles and their parts, okay? So if 2 triangles are similar, then the following corresponding parts are proportional to the corresponding sides. I'm going to highlight that for us. Proportional to the corresponding sides. Okay? So if you guys remember from Unit 4, and we talk about it all the time, the altitudes of triangles are the perpendicular height, okay? The perpendicular height. So we will create a proportion where we get to say the altitude of the first triangle over the altitude of the second triangle will be proportional to any two corresponding side lengths of the triangles. So I could pick AB to EF, I could pick BC over FG, or I could pick AC over EG. It does not matter which ones you pick. Okay, I'm going to just go ahead and pick AB and EF since those are the closest ones that are corresponding. So it will create a proportional relationship to AB over EF. Okay, so if you have two similar triangles, the altitudes ratio will be equal to the corresponding side lengths ratio. Okay, same thing works with the angle bisectors. If I have two triangles that are similar, the angle bisectors, so let's go ahead and say our first angle bisector is QS over the second angle bisector, which is UW, will be proportional to two corresponding side lengths. Does not matter which ones you pick. Okay, so I'll do the same thing. I could pick QP and UT. I could pick QR over UV or PR over TV. I'm going to go ahead and do the ones closest to me, which are side length QP to UT. Okay? So the ratio of angle bisector to angle bisector will be proportional to side length to side length. And the same thing goes with the medians. The relationship of the medians, so I'm going to write HJ over LN will be proportional to corresponding side lengths of the triangles. So I'm going to do GH and KL. Okay? So we're going to look at our next four examples, and they tell us in each of these examples that my triangles are similar to each other. We have to have a similarity statement in order for us to know that they are similar, unless we wanted to prove it by the angles and the sides being proportional. Okay? So, first thing we're going to look at is we're going to figure out what part of triangles are we talking about here. So, I'm going to highlight the parts, and I'm going to try to figure out, we don't really have to figure out what kind of part this is, but I think it's good for us to know. This intersects that side into two congruent collinear segments, right? So we know this would have to be a median because it splits the opposite side into two congruent parts. So our medians say that the relationship of the medians, so I'm going to go ahead and put median 1 over median 2, will be proportional to two sides that are corresponding together. So I'm going to pick a side on my first triangle, and I'm going to call my first one 16. I have to make sure that I pick the corresponding side of the second triangle to go with it. So 16 is the length from S to T, and you'll notice in our similarity statement, ST is the first two letters, so I have to make sure that I pick DE on my second triangle. So I know DE and ST will be proportional. Okay? So now we have a proportion, just like we've been doing this whole time. And we would solve our proportion by cross multiplying, and we end up getting 12 for our x value. Okay? On number 2, we have some altitudes in our two similar triangles. We know they're similar because of our similarity statement, and we know that the relationship of altitude to altitude will be proportional to side length of triangle 1 to corresponding side length triangle 2. So only other triangle or only other side length that I have listed on this first triangle is where this x is located. So I have to make sure I pick the right side of the second triangle. So IH or HI are the second and third letter. I have to make sure that I pick LK on my second triangle because those are the ones that are corresponding to each other. Okay? We would cross multiply and end up getting 17.5 for our X value. Okay? Now let's look at an angle bisector. I know these are angle bisectors because of the congruent arcs on angle C and angle F. So we know that the relationship of angle bisector 1 over angle bisector 2 will be proportional to the corresponding side lengths. The only other side length I have on my first triangle is side AC, which is 38. So I have to make sure that I use EF's side length to make sure that they are corresponding to each other. Okay, set up our proportion. We're going to cross multiply. And we get, what is that, 28.5. There we are. Okay. Forward looks a little bit different. The only reason is because the altitude is on the outside of the triangle. That's okay. You would still do the same thing. Altitude to altitude is proportional to side length to corresponding side length. Okay. And our last page. This is a fun one, number 5. It tells us that triangle KYC is similar to BLH. And if we look at our picture, we have some medians involved. These are medians because they separate the third side into two congruent pieces. Okay, so we get to say that the median over the median will be proportional to the corresponding side lengths. Let's make sure that these are right. CY, our second and third letter, LH, second and third letter. So we are good to go. If I started with my first median, I have to start my second ratio with my first side length of triangle 1. All right, we're going to see how this one's a little bit different. You'll notice now that we have a binomial times a binomial, so we are going to have to do some fun stuff here. Okay, so I'm going to go ahead and write it out. So we have x minus 5 times, what is that, 2x minus 9 equals 15 times 20, which is 300. Make sure that we don't just do x times 2x is 2x squared, negative 5 times negative 9 is 45. You can't just do that. You would be missing two middle terms here. If you have a binomial times a binomial, there are 4 terms that you should be getting out of this when you multiply. Okay, so 2x times x is 2x squared. Negative 9 times x is negative 9x. Negative 5 and 2x is negative 10x. Negative 5 and negative 9 is positive 45. Okay, we're going to start combining our like terms here. You guys will notice that there's an x squared, so that means that we're probably about to factor. Okay, so I'm going to set up my quadratic into standard form so that we can factor this. That's 55. 255 equals 0. There we go. All right. So I'm going to give you guys a second to try to figure out what our two factors are. You can factor this by grouping like we've been doing in our warm-ups. So I'm going to give you guys a couple of seconds to try to figure out what our two factors are. Put this quadratic in factored form. And you should get a factor of 2x plus 15. and one of your other factors is x minus 17. If you were to solve for x for both of these, you'll notice that if x minus 17 equals 0, x equals 17 would be one of our x values. And my other x value would be negative 15 over 2. Since we're referring to side lengths of triangles, if I replaced my x value with negative, we would end up with a negative length, and that will never work. We cannot have negative lengths. So let's put a little note. Doesn't work. So the only x value that does work in this situation is x equals positive 17. Cannot have negative side lengths. All right, and our very last theorem is the triangle angle bisector theorem, which says an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. Okay, so the angle bisector, here's our angle bisector, separates the opposite sides of the triangle, okay, the opposite sides, into two segments that are proportional to the other two sides. So in other words, we can say that the length of AD to DC is proportional to the lengths of the other two sides of the triangle. So AB to BC. Okay, you'll notice that the side of AD is associated with the side, do you see what I'm saying here? So AD and AB go together, DC and BC go together. You want your proportions to be set up that way, okay? So in our pictures down here, we don't see anything in our picture that lets us know that we have an angle bisector, but it tells us in our directions that KM represents an angle bisector, okay? So if KM is an angle bisector, we're going to follow this theorem. Okay, it separates the opposite sides into two segments. So it separates the opposite side into two segments that are proportional to the other two sides. So we're going to start with 4.8 to the other side. So it separates the side of the triangle. So if I chose 4.8 first, I'm then going to choose 12 first, because that's the part of the triangle that it belongs to. Okay, 12 over 18. So one more time. If we have an angle bisector, okay, it separates the opposite sides. So the opposite sides separates them into two parts that are proportional to the lengths of the other two sides. So once we cross multiply here, we're going to end up getting 7.2. Okay. 7.2. Let's go ahead and jump to number 8. If we have an angle bisector, which it tells us that we do, then that angle bisector separates the opposite side. So we're going to do the separation here. So I have side 15. I need to figure out what the length from M to L is, which is what? 39 minus 15 is 24. So 15 over 24 will be equal to the other two sides. So X over 36. So we are just doing a billion proportions today. So if I multiply these, we end up getting an X value of 22.5. Okay, let's do one more, and then you guys have a lot of time to practice. If, oh, this one's different. This one says find the value of KL. We need to find that value of KL here. Okay, so if KM is an angle bisector, we're going to follow that theorem again. Then it separates the third side, the opposite side, into two parts. We need to figure out the length from M to L here. So 45 minus 27 is 18. So 27 over 18 will be proportional to, I'm going to pick the side that's on the triangle with 27 first, 3x minus 9 over x plus 11. Okay, we have some binomials in this proportion, so we have to be careful here when we're cross multiplying. So I'll have 18 times 3x minus 9, which will be equal to 27 times x plus 11. And if you guys would, go ahead and solve for your x value. Okay, and it doesn't want us to find x, it wants us to find the length from, or the length of KL. So if we replaced x with 17 here, we would find out that the length of KL is 17 plus 11, which is 28. All right, you guys now can practice on your homework. Have fun.